All right, let's knock this out real quick, and then you guys can get out of my face. I mean, go home. Uh, the diameter of a Douglas fir tree is currently 10 inches when measured at chest height. Over the next 50 years, the diameter is expected to increase by an average growth rate of 2/5 inches per year. The equation y equals 2/5 x plus 10 gives y the diameter of the tree in inches after x number of years. Draw a diagram, or I'm sorry, draw a graph of the equation and describe the relationship. So this is like x comma y. So I'm going to plot the point. Remember that when we plot points, it's x comma y. So my first point, when x equals 0, what does y equal? 10, right? So all I'm doing, these are the x's, these are the y's. When x equals 0, y equals 10. That's one point on the graph. What's another point on the graph? How about 10 comma, when x equals 10, what does y equal? 14, very good. When x equals 20, what does y equal? 18. And then we have 30 comma 22. And then we have 50 comma 30. So this is what they want us to plot on the graph. So, oh, hey, it's already done for us. 0 comma 10, blah, 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 blah. It says that the relationship is non-proportional because it doesn't go through the origin. It's not going through this point here. By the way, I should point out that the y-intercept occurs at 10 when x equals 0. Notice that my equation, my original equation, has a b value of 10. So when we say y equals mx plus b, this value right here is the y-intercept. Okay? And m is the slope. So if I were to say, hey, boys and girls, tell me what the slope of this equation is, what would you say? Ask my math teacher. That's a good one. How about 2/5? What does that represent? 2 is my rise, and 5 represents my run. So you want to see something cool? If I go up 2 over 5, I stay on the line. Does that make sense? Go back. Write this down and quit talking. So that's it. Does anybody have any questions on this? Oh, one last thing. Let's graph this in a graphing calculator so you guys can figure this out. Turn on your graphing calculators, ladies and gentlemen. Shh. Stop talking. I'm recording still. You know what that means? Evidence for when I call your parents. All right, let's view the large display here. All right, here we go. Go to y equals. Clear this out. Remember the y equals button is this one right here. So let's enter in this equation. So to enter in a fraction, what button do I hit? Math. I'm going to go to over here. That gives me the box over the box. We had 2/5, correct? Times x. Here's the x button right here. And it was plus 10, right? So here's another thing I want to show you too that's kind of nifty. If I look at this graph, what's my lowest x value of the graph? 0. What's my highest x value of the graph? 50-ish? We'll say 60. Go ahead and hit window. My lowest x value was 0. My highest x value was 60. Let's do the same thing for the y values. Y values go from 0 to 50, roughly. So I'm going to say my y minimum is 0. My y maximum should be what? 50. Now when I hit graph, my graph looks a lot like the graph that we have. When x equals, remember x represents the number of years, so 10 years after the initial measurement, what will the diameter be of the tree trunk? 14 inches. See how that works? What about 20 years? 18 inches. See how that works? Let me take a screenshot of this so we could get in here and see what this looks like. And it matches up perfectly. We said that at 20 years it'd be 18, right? Well, that's exactly what the graphing calculator said. Okay. That was my watch. Get on my level. You guys probably take phone calls on your phone, don't you? Oh, that's the end of the video.